Imagine the sky filled with a blazing fireball, a mountain-sized rock hurtling toward Earth. It sounds like a sci-fi thriller, but Earth has actually been struck by big space rocks before, and could be again. About 66 million years ago, approximately 10 kilometers asteroid slammed into Mexico, forming the 125-mile-wide Chicxulub crater and causing the extinction of about 75% of Earth's species. With a catastrophic image like that in mind, let's break down what actually happens if a giant asteroid strikes and how and whether we can survive it. Space is full of rocky debris. Most small meteors burn up harmlessly in our atmosphere every day, but occasionally a larger near-Earth asteroid comes close enough to be worrisome. Telescopes around the world are constantly scanning the sky to find these objects. Asteroids that do strike usually fall into two categories. Smaller ones, tens of meters wide, tend to explode high in the atmosphere. For example, the 1908 Tunguska event was caused by approximately 40 meters rock that blasted apart 10 kilometers above Siberia. The shockwave flattened trees over an 830 square mile area, roughly a small state's worth of forest, knocking down approximately 80 million trees in a butterfly-shaped pattern. Now, imagine a truly giant asteroid, say 10 kilometers across, the size that probably wiped out the dinosaurs. Asteroids hit Earth at very high speeds, typically approximately 20 kilometers per second. At impact, it would release so much energy that the immediate effects would dwarf all local destruction combined. A crater the size of a small country would form, ejecting trillions of tons of debris into the atmosphere. Here is a simplified sequence of what happens during such a colossal impact. The impact and air blast would instantly incinerate or obliterate everything within a region, possibly hundreds of kilometers wide. Intense heat would ignite fires for miles around the crater, and a supersonic shockwave would flatten forests and man-made structures out to great distances. In a few seconds, tremendous quantities of pulverized rock, dust, and soot would be flung high into the stratosphere. This debris forms a global dust veil. By the way, even impacts into the ocean would loft spray and dust similarly. The high-altitude dust and soot would block sunlight for months or even years. Temperatures worldwide would plummet. Computer models show a 500-meter asteroid impact, much smaller than 10 kilometers, can cause global cooling of up to approximately 4 degrees Celsius, with rainfall dropping approximately 15%. In short, a giant asteroid would not only wipe out the local area of impact, but it could destabilize global climate and ecosystems for years. All this doom sounds terrifying, but here's some good news. We have a planet-sized network focused on spotting asteroids before they hit. Of course, finding an asteroid is only the first step. We also need ways to deflect it. This is where missions like NASA's DART come in. In 2022, NASA deliberately crashed the DART spacecraft into a small asteroid moonlet to test deflection. It worked. The asteroid's orbit was measurably changed. So, should you be paralyzed with fear or pack an apocalypse bunker? In reality, the odds of a 10-kilometer asteroid hitting Earth in the next few centuries are vanishingly small. Thanks to sky surveys, astronomers have cataloged almost all big near-Earth objects and found no imminent threats.